Welcome to DSA Logic. I'm Sheetal Chandra Nayak, a senior software engineer at Walmart Global Tech. Let's see what we'll be learning in this video. We'll be learning about arrays, linear search, linear approach, arrays with Java 8, time complexity of traditional approach, and time complexity of Java 8 approach. So let's start. When we talk about arrays, there are multiple ways to define it. Let's take a look at some of them. The most popular one is giving the data type with a square bracket and a variable to it and using a new keyword to initialize it. When we are initializing, we have to give the size of the array because array is a fixed size data structure. Whenever we need a fixed size data structure, we can always consider arrays because this is the base of most of the data structures. Now, this placement of this square bracket does not matter that much. You can place it here also, but I prefer the other way because this way, while reading it, I get to know here only like it is an integer array and ARR is the variable name. Now, let's take a look at defining some other types of array. Let's define a long array. Long, and change this also to long. Now we have a long array with us. Can you define a string array? Obviously, yes. Let's change the type, the variable name, and the type again. When these are all about like when we have predefined types in the Java. Now, if we have a custom data type, or let's say class, so let's create an employee class. I'm keeping it empty for now. I don't need to put variables in that. So I can even define an employee array. Employee, putting a square bracket, giving the variable name, and using the new keyword to define the array. I again have to give the size, and now I have an employee array. There is one more way to define an array. That is giving the data type with the square brackets, giving the variable name, and directly giving the values in the curly braces. Let's say 9, 3, 5, 1, 6, and 8. Oops. So this is also equally valid. This is mostly used when we are doing some kind of programs for our learning purpose and all, because we don't have to create this array and assign each index the value one by one. So for this lecture, we will be using this kind of representation of the array. So let's get rid of the rest of them. And we don't even need this. Now, let's take a look at a very common program like searching an element in the array. Let's say we have an element which we want to search in the array. Let's say that is 6. So by searching, what I mean is we want to get the index of this element from this array, and these things will change every time. So let's try to write a method for it. Public, I'm calling it static so that I don't have to create the object of this class. So we want to get the index out of it, right? So index is an int variable, and let's call this method search. Now let's talk about the parameters of this method. The parameters will be an integer array and element which we want to search. Okay. Now, how do we search an element in the array? Basically, what we do is we loop through this array and for each index we try to check if that matches with this particular value or not. No, here, no, and like this. Here, yes. So we get the index out of it. Let's try to code it out. Let's try to get a for loop. It's starting with 0 as the array index starts with 0. Then what should be the condition? The condition is basically I should be less than array length. Now, so now we have a loop which will loop through all the elements. Now we need to test it out, like if this particular index is having the value equal to the given element or not. So to get the element of a particular index, we can use the variable name. In the square bracket we can give the index, and then let's check it out, like if these two are equal or not. So once these two are equal, we are good. We already got our solution, so we can return the value as I was the index of the array where we found the element which is equal to it. So we are good with this part. Now what happens when we don't have the value in the array? Now we are searching for 6, it is there, but let's say I'm searching for 10 which is not there in the array. So let's write a default case for that. Let's return -1 when we don't find an element in the array. Now let's test it out. Search, giving the array and the element. Let's test it out. So we got 4. Let's check if it is correct or not. 0, 1, 2, 3 and 4. Oh, that's cool. That's correct. Let's try for some other elements. Let's try for 11, which is not there in the array. Let's try for something which is again there in the array. Let's say 9. Now you see, we have all these things. So for 6, the index is 4. For 11, the index is -1, and for 9, index is 0, which is absolutely correct. Now, what do we call this particular algorithm? We call this linear search. Linear search basically means searching the elements in a linear way, like in one by one way. I have a spelling mistake here. Now, if we talk about the time complexity of it, what should be the time complexity of it? So, time complexity of this is directly proportional to the number of array elements. So, if we have n elements, then this loop will go n times, and n times we'll be checking this. Yeah, sometimes like in this case, like at the first index we got the value, but in the case when it was 11, we loop through all the things and we never find the value. So we can roughly we can assume like we have to loop through for each case we have to loop through n times, because n is the size of the array. So we can say this time complexity of it is O of n, because it is directly proportional to it. This is about linear search. So when we are searching an element in a linear way. Is there other ways to search? Yes, it is, and we will see them in the further videos. But for now, let's enhance the linear search a little bit for doing some more operations. Let's say we wanted to find a maximum value of this array. Okay, and let's call it find max. We don't have this method. Let's create this method. So max value will again with the same data type which we have, which the array is. So let's change it to int, and now we want to find the maximum value out of this array. That is very similar to this because what we are going to use is a linear approach. So let's copy this. Now, when we are finding a max value from an array, we need a value which can hold the max value of the array. So let's call it max. And we have to initialize this. If it is a max value you need to find, initialize with always the minimum value available. So the minimum value is integers minimum value. So if you see, that is this value. Okay. Now at the end, once we are done computing, we can return this max value. Now about the logic part. So in the previous case, we were checking if it was equal to the given element, but right now we don't have a given element. So what we need to check is if the given element, if the current element is greater than the max element. At the beginning, it was the minimum value. So whatever the first element will come, that will become the max. That will be the max element. Now let's reassign this max value when this condition is true with ARR of I. With this code will loop through the array, check any time whenever this ARR of I means the current element is greater than the max value, we are changing the max value and we are reassigning it with the current element, and this way we will find the max value out of the array. Now let's test it out. So we see 9 is our max value. Now let's try to put one more max value here. Let's make it 10, and let's rerun the program. Let's put some things to identify it. Max value. Okay, let's rerun it. Now we can see the max value is 10. So our code is working fine. Now let's try to get the minimum value also, and then we will talk about how this is similar to the previous one and how it is related to the linear search. Let's talk about min, and let's refactor this max to min. Now as we are trying to find the min value, let's use the max value here, and the only change which we need to do is changing this condition like this, and we are good to go. Let's test it out. Let's call it min value, and here let's change the method name to min, and we are good to go. Let's try it out. So max value is 10 and min value is 1, which both are correct, right? Now let's try to think about how it is similar to the linear approach. Okay. Now here also see we only have one for loop which is looping through this array elements, which is exactly similar to this one. Now only the part which is changed is this particular part, which is the processing part. That's why we can call it a linear approach. Okay, and as it is a linear approach, it is again having a time complexity O of n. Now so we can say like finding max element, finding min element. If we want to do some other kind of computations like sum all the elements of the array, all these kind of things are using linear approach, not linear search approach. Okay, again a spelling mistake here. steps. Now we have one more way to do all these things. So in Java 8 there are some inbuilt things which we can use to find these kind of operations, like finding max, finding min, and like even the searching of the element also. Let's try to do use Java 8 also while we are doing this. So let's create a method which is similar to this, but let's call it with Java 8. Now when we are using Java 8, we don't need to use all of this. What we just need is arrays dot stream, spelling mistake, dot stream arr, which is our array, and we directly have a max function here which we can use, max, as it returns an optional of int. This is something we can talk in further videos, or you can look about optional, how it works with Java 8. So we need to get the int value, get as int, and we are good to go. This max value with this much code is reduced to one liner. Same thing can be done with the min value also. Let's take it, let's change it, and let's take our this particular code, replace it here, and rather than saying it max, let the min with Java 8. Let's test it out, like does it works well. So here we can call with Java 8 and find max with Java 8. Let's call this with Java 8 again and find min with Java 8. Let's try to run and test it out. Now we can see our traditional code and our Java 8 code, both are giving the same answers. So depending upon the situation, you can try to use any of these. This is this is very necessary to know, because here you have more control over it. Let's say you want to do something which function is not there with this Stream API, then this is very much helpful, knowing this approach. Now when we do like this, what should be the time complexity of this? Is it like the Stream API is going to change the time complexity also? Actually no, the time complexity will again remain the same, because again it is using a linear approach, and we are checking each element. For the Stream API is internally doing checking of each element in a stream way, and finally the approach is always having the time complexity of O of n. So don't confuse when somebody is using Stream APIs and somebody asks you about time complexity. Always think about in this way. If you would have done it in this way, what would be the time complexity? So same is the time complexity for this way also. So that's all for today. Hope you liked it. Thank you so much. And if you liked it, please subscribe to my channel DSA Logic and stay tuned for more such content. Thank you.